The screen fills with the shimmering, impossible geometry of a quantum circuit. Qubits entangle in superposition in a silent digital ballet. This isn't just faster computing. This is a fundamentally new form of mathematics made physical. It is a technology that promises to solve in seconds what would take today's most powerful supercomputers longer than the age of the universe to crack. And right now, the world's superpowers are engaged in a secret multi-billion-dollar arms race to control it. This is not just about technological superiority. This is about economic dominance, national security, and the future of human civilization itself. The quantum race is on, and the stakes could not be higher. The core principle that makes quantum computing so revolutionary and so terrifying lies in the bizarre laws of quantum mechanics. Unlike a classical computer bit, which can only be a 0 or a 1, a quantum bit, or qubit, can be both 0 and 1 simultaneously. This state is called superposition. Furthermore, qubits can be entangled, meaning the state of one qubit is instantly linked to the state of another, no matter the distance between them. This allows a quantum computer to explore a vast number of possibilities all at once. To understand the difference, imagine a gigantic maze. A classical computer must try each path one by one. A quantum computer can, in a sense, try all paths simultaneously. For specific, massively complex problems, this provides an advantage so profound it is called quantum supremacy. The most immediate and alarming application of this power is in cryptography. The entire digital world, your bank transactions, your private messages, government secrets, military communications, is protected by encryption. This encryption, like the RSA algorithm that secures the internet, relies on the mathematical difficulty of factoring very large numbers. For a classical computer, factoring a 2048-bit number could take billions of years. For a sufficiently powerful quantum computer, it could take minutes. This is the coming cryptographic apocalypse. Every secret, every financial record, every piece of critical infrastructure currently protected by classical encryption would be laid bare. The nation that achieves this first will hold the ultimate skeleton key to the digital world. This terrifying prospect is why the world's two technological titans are pouring unprecedented resources into the race. The United States, through its National Quantum Initiative, has committed over $1.2 billion in federal funding, with tech giants like Google, IBM, and Microsoft adding billions more of their own capital. In 2019, Google's Sycamore processor famously claimed quantum supremacy by performing a calculation in 200 seconds that would take the world's fastest supercomputer 10,000 years. IBM is betting on its Condor and Flamingo processors, relentlessly pushing the qubit count higher. Their strategy is a full-stack approach, building not just the hardware but the software and cloud access to it. But America does not have a monopoly on quantum talent or ambition. China has declared quantum technology a national priority, with estimated state funding dwarfing that of the US. In a stunning demonstration of their progress, Chinese researchers used a quantum satellite called Moonshot to achieve quantum-secured communication over a distance of 1,200 kilometers. They are building a quantum Great Wall, a national network that would be impervious to any form of eavesdropping, even from a quantum computer. The Chinese tech giant Alibaba is also deep in the race, making significant strides in both hardware and software. This is a Cold War fought in university laboratories and corporate R&D centers, and the prize is nothing less than the future of information itself. The battlefield, however, extends beyond national borders to a fierce war for human capital, the brain drain. The number of people on the planet with the deep expertise to build a quantum computer is vanishingly small. Nations and corporations are engaged in a frantic bidding war for these rare individuals, offering multi-million-dollar salaries and unparalleled research facilities. The country that can attract and retain the best quantum minds will have a decisive, perhaps insurmountable advantage. This has led to rising geopolitical tensions, with accusations of intellectual property theft and restrictions on the flow of students and researchers between the US and China. Beyond breaking codes, the potential positive applications of quantum computing are staggering. It could lead to the rapid discovery of new life-saving drugs by simulating molecular interactions with perfect accuracy. It could design entirely new materials with bespoke properties, from room temperature superconductors to ultra-efficient batteries, solving the world's energy crisis. It could optimize global logistics and financial modeling on a scale that would revolutionize entire industries. The economic reward for the nation that commercializes these applications first is estimated to be in the trillions of dollars. So, where are we now, and when will a truly useful, fault-tolerant quantum computer arrive? The current era is what experts call the NISQ era, noisy intermediate-scale quantum. Today's quantum computers are fragile and prone to errors. Their qubits are unstable, and they require incredibly complex cooling systems to operate at temperatures colder than deep space. The grand challenge is to build a machine with enough stable, logical qubits to perform useful, error-corrected calculations. Estimates vary wildly, but most experts believe we are still at least a decade away from this milestone. The progress, however, is exponential. For the average person, this race may seem like an abstract contest between scientists, but its outcome will define the next century. It will determine which nations and corporations hold the keys to global security, economic power, and scientific discovery. The quantum future is not a question of if, but of when and who. The countdown has begun. The race is on. And the world that emerges on the other side will be unrecognizable to the one we live in today.